This chart shows the time and effort involved in creating something using a common or traditional design process, or build, test, fix. The horizontal axis represents design time, which includes all the steps needed to come up with a final manufacturing prototype. The vertical axis represents cost per unit time, which is a measure of how much we spend over time. The first cost associated with a traditional design process is the initial raw design effort that gives us the plans or blueprints for a baseline prototype, which is something that can work now. Once we have this prototype, we need engineering support to turn it into a workable design. This means making it manufacturable, easily assembled, interfacing with its operating environment, transportable, and so on. And once we have a workable design, we need to certify it somehow against specifications or requirements to ensure that it is usable for our customers. This sounds like a sensible approach, but that's only because it ignores all the effort we have to spend on eliminating failure modes and mechanisms discovered during testing and inspection. In other words, fixing preventable problems. This effort is unnecessary and consumes time and money. So let's move away from this traditional design process and start using the quality and reliability mindset. Firstly, designing with a quality and reliability mindset involves at least twice the initial raw design effort to create our first configuration or design. This is because we are busy using Vermeers and fault tree analyses and HALT and lots of what we call design for reliability and quality tools to make sure our first design is a reliable design. People like the infant manager hate this because taking the time to identify likely future failure modes gets in the way of achieving the next milestone as quickly as possible. The infant manager cannot demonstrate cost savings or schedule improvements from day one unless they remove everything they consider unnecessary. And sometimes the first key milestone is creating a baseline prototype. So the infant manager often doesn't let us slow down enough to actually use all that wonderful corporate and engineering knowledge that our organization's quality brochures say we have. But when we do invest this effort up front, we start with very few failure mechanisms we need to eliminate. The engineering support we require has also been minimized because the quality and reliability mindset includes high quality manufacturing, assembly, packaging for transportation, and other product characteristics our customers value. Vermeers also include corrective actions that essentially become our test, validation, and verification plan, which makes certification fast and efficient. And we also have more time and money to think about how to incorporate new smart features that one day might make us a true market leader. So let's compare the effort associated with designing with a quality and reliability mindset to the effort associated with the traditional design approach. You can see how much time and money is saved when using the quality and reliability mindset. Research shows that design and production can be 73% cheaper and development time can be halved. And the final product is all but guaranteed to be more reliable, simply because we use the quality and reliability mindset. And this happens because we make our first design a reliable design. These profile curves, figures, and costs are not made up. The research I mentioned came from an academic study of liquid fuel rocket engine production, using both the traditional design approach and designing with a quality and reliability mindset. Waiting until failures occur during a build, test, fix process should be an archaic way of producing something, but it's still common, and this means your competitors will be spending lots of time and money making products that are less reliable than what yours could be.